Hello everyone. Today we are going to discuss about Kirchhoff's current law and Kirchhoff's voltage law. Let us start with Kirchhoff's current law, or we also call it as KCL. KCL states that at any junction, the sum of incoming currents is equal to sum of outgoing currents, or we can take an example to understand it better. Let us take a junction or a node where we'll be having incoming and outgoing currents. Let I1 be the current incoming, also I2 be the current incoming, I3 be the current outgoing current, I4 be an outgoing current, and let I5 be an outgoing current. If this is a junction J, at a junction J, we can state at junction J, the incoming current or the current entering the junction, we can also call it as the current entering the junction, entering the junctions are I1 and I2, and outgoing current or the current leaving the junction are I3, I4 and I5. Junction they are leaving, I3, I4 and I5 are leaving, I3, I4 and I5. Therefore, from the statement at any junction, the sum of incoming current or the current entering the junction or will be equal to the sum of outgoing currents or the currents leaving the junction. Therefore, incoming currents are I1 plus I2. Sum of incoming currents is equal to the sum of outgoing currents. Outgoing currents are I3, I4 and I5. Okay, let us take a better example of how this KCL acts in a circuit. Okay, let us consider a circuit where we'll be having a parallel and series connection of resistors with voltage V acting. The current flowing in the circuit is I, and the branch currents are marked here. I1 flowing through R1, I2 is flowing through R2, I3 is flowing through R3, I4 is flowing through R4. Similarly, I5 is flowing through R5. Okay, and the total current leaving is I, the incoming current. Now, at this point, we do have junctions J1, J2, J3 and J4 junctions. Now, at any junction, as the statement said, let us start with junction J1. At junction J1, the incoming current is I. It will be equal to the current leaving the junction are I1 and I2. I1 plus I2. Similarly, at junction J2, here is junction J2, incoming current is I1 will be equal to the outgoing currents I3 and I4. I3 plus I4. Now at junction J3, and here is junction J3. At junction J3, incoming current is I3 and I2. We can mark it as I2 plus I3 will be equal to the current leaving the junction is I5. Okay, similarly, the last junction at junction J4, the current entering the junction J4 is I4 and I5, and the current leaving the junction is I. Okay. Hope you people understood the concept of KCL. You can recall the statement as at any junction the sum of incoming currents is equal to the sum of outgoing current. That's what KCL states. Okay. Similarly, moving on to the KVL or Kirchhoff's voltage law. KVL. KVL states that the algebraic sum of voltage drop in a closed path or mesh in a specified direction is 0. Okay. It states that the algebraic sum of voltage drop in a closed path or a mesh in a specified given circuit is 0 in a specific direction. Okay. And if voltage drop is taken as positive, then voltage rise is taken as negative, or vice versa. To understand this, let us consider a simple network where a voltage source V is connected with resistor R1 and R2. Let the current flowing in this network be I. Okay. In this case, voltage drop are nothing but the resistance where the voltage is dropping R1 and R2. If we are going to take these voltages as positive, then the voltage rise, that's the supply voltage, the active element, will be taken as a negative. Okay. To understand, let us take this voltage rise as negative minus V, and the voltage drops at R1 and R2. Okay, let the voltage drop at R1 be V1. What is the value of V1? V1 will be the current times R. The current flowing in the R1 is I into R1, that is plus I into R1, and here the voltage drop would be V2, and the voltage value is I times R2 will be equal to 0. That means the algebraic sum of the voltage drops in a closed path or a mesh, in a specified direction. We have taken the current flowing in a unidirection is 0. Okay, or we can also write it as on rearranging the terms, if minus v gets to the other side, v is equal to I into R1 plus I into R2. Okay, hope you people understand KCL and KVL better. If you have any doubts or clarification, please do comment below. Thank you.